Chapter 11, Sample Surveys. So a population is considered to be an entire group of individuals, and a sample is a smaller group selected from that population. A bias sample is when you over or underemphasize some characteristics of the population. And when that happens, your conclusions are flawed. There's usually no way to fix after the sample is drawn, and there's no way to salvage any useful information from the sample. So randomizing protects us from the influences of all the features of our population by making sure that on average the sample looks like the population. So you might ask, why not match the sample to the population? So rather than randomizing, we could try to design our sample so that the people we choose are typical in terms of every characteristic we can think of. Well, the problem with that is, what about the characteristics that you cannot think of? It'd be very difficult, if not impossible, to match the sample to all of the characteristics in the population. So let's talk a little bit about sample size. So the sample size is the number of individuals in the sample. And it's the number of individuals in the sample that is important, not the number of individuals in the population. So let's think of an example. Let's say you're cooking a pot of soup for a few people. So in order to know how the soup tastes, you only need to sample a spoonful. You don't need to eat the whole pot of soup. You don't need to eat a whole bowl of soup. A spoonful will be a large enough sample for you to know how the soup tastes. Now, let's pretend you're cooking this pot of soup for a banquet. Now, the pot is much bigger because you're cooking for more people, but you still only need to sample a spoonful to determine how the soup tastes. You do not need to sample a whole bowl, and you do not need a bigger spoon. The same size spoon will still work for both situations. So a census is a sample of the entire population. So the question might arise, why not just take a census rather than taking a sample? Well, the problems with taking a census: number one, it's very difficult. Number two, it's very expensive. And number three, it would take too much time. When you hear the term parameter, that refers to the population. And when you hear the term statistics, that refers to the sample. Statistics computed from a representative sample reflect the corresponding parameters accurately. A bias sampling methodology tends to over or estimate the parameter of interest. So below is a table of some terms that we've discussed already: mean, standard deviation, correlation, regression coefficient, and proportion. And then we have columns for the notation for statistics and the corresponding parameter. In a simple random sample, every possible sample of the size we plan to draw has an equal chance of being selected. The sampling frame defines where the sample will come from, and sampling variability is the sample-to-sample differences. So samples drawn at random generally differ from one another, and each random draw selects different subjects from the sample. This leads to different values for variables that we measure. In a stratified random sample, the population is first sliced into homogeneous groups called strata before the sample is selected. Simple random sample is used within each stratum before the results are combined. Stratifying can reduce the sampling variability. In cluster sampling, we split the population into representative clusters, and then we select clusters at random and perform a census within each of them. Clusters are generally selected for reasons of efficiency, practicality, or cost. So you may ask, what's the difference between cluster sampling and stratified sampling? Well, in stratified sampling, the strata are homogeneous and differ from each other. Clusters can be heterogeneous. The randomly selected clusters provide a representative sample of the population. For multi-stage samples, we use multiple sampling methods to arrive at our sample. For systematic samples, we randomly select a starting point and then we select every nth subject for our sample. So the way to design a valid survey, first know what you want to know. Okay, understand what you hope to learn and about whom you hope to learn it. Next, use the right sampling frame. Obtain your responses from the appropriate respondents. Next, you want to tune your instrument. Longer survey instruments tend to yield fewer responses. Also, ask specific rather than general questions, and ask for quantitative results when possible. You also want to be careful in how you phrase your questions, because the respondent may understand the question different than you intended. Also, you can run a pilot, which is basically a trial run of the survey that you eventually plan to give to a larger group. So use a draft of your survey questions administered to a small sample drawn from the same sampling frame that you intend to use. Now take the results from this pilot, analyze them, and discover ways on how you can improve the survey instrument. So here are some examples of how to sample badly. So these are some things that you want to stay away from when you're designing an experiment. So mistake number 1 is to use sample volunteers. So a large group of individuals is invited to respond, and those who choose to respond are counted. Now, the problem with this is the respondents, rather than the researcher, are deciding who will be in the sample. Okay? Your results will almost always be biased, so your conclusions are almost always wrong. This yields voluntary response bias, and it's biased towards those with strong opinions or strongly motivated. People with strong negative opinions are more likely to respond than those with strong positive opinions. So mistake number 2 is to sample conveniently. Now this includes individuals who are convenient for us to sample, and they may not represent the population. Mistake number 3 is to use a bad sampling frame. Incomplete sampling frame introduces bias due to those included differ from those not included. And mistake number 4 is under coverage. Some portion of the population is not sampled at all, or has a smaller representation in the sample than it has in the population. So when you have non-response bias, you have a large portion of those sampled do not respond, and those who do not respond may differ from those who do. You can also have response bias, which is anything in the survey design that influences the response. Something important that I want you to keep in mind is a better designed survey is superior to a bigger sample size.